Let's talk about the stars and the universe. So first of all, let's discuss the universe. The universe is made up of different galaxies. Each galaxy is made up of many billion stars. The sun is the solar star in our universe, and it's existing in the Milky Way. Of course, there are some other stars in the Milky Way which are much further away from the Earth. That's why we don't see them as luminous as the sun. They are astronomical distances away from Earth, and we measure those distances in light years, as they are existing in the vast vacuum of space. The Milky Way and the solar system. So our solar system is not the only solar system existing in the galaxies. There are potentially billions in different galaxies, and we estimate that there are more than 100 billion galaxies in the entire universe. The distances between stars and galaxies measured from Earth is measured in light years, as they are quite far from us, and 1 light year is approximately 9.5 10 to the power of 12 kilometers. Let's discuss the life cycle of stars. All stars were made out of giant gas cloud called the nebula, and due to the gravitational pull to the center of the cloud, the hydrogen gas and dust collected were concentrated or pulled together into the center and made a hot ball of gas known as a protostar. The protostar then pulled the particles together and created a more dense protostar, and then more frequent collision happened in the center of that protostar, where particles increased the temperature of its core. Once the temperature was high enough, nuclear fusion will occur, and then we call this a main sequence star. So a main sequence star becomes hot enough for nuclear fusion to take place in its core, where hydrogen gets fused or get into a reaction to form helium. This fusion gives out or releases energy in the form of heat and light, where we can see from an example of our sun, where the sun releases heat and light in this fusion reaction. So depending on the size of the star, like if it's a medium or low size star like the sun, then this process will keep consuming hydrogen, and then hydrogen will run out eventually, and the sun will expand to form a red giant. And due to this expansion, the sun will eventually explode to form a planetary nebula, and after that a white dwarf. So a white dwarf will be a very dense core, which mostly made out of electron that was disintegrated from the matter of the red giant. And then the white dwarf will fade away and become less luminous to form a black dwarf. If we talk about a more red supergiant, a larger star, the larger star will also expand and contract in a cycle, and then will create a supernova explosion. That explosion can result in two outcomes. One of them is forming a neutron star, where the core of the star is mostly made out of positively charged protons and negatively charged electrons, which combine into a neutron. And then the other option is having a black hole of a very dense mass that absorbs all the light that goes through it or comes near it. Let's talk about the life cycle of stars in a different format, which we talk about in terms of luminosity and also size and temperature. So the more luminous the star is, that depends on its size and also its temperature. So a very large star, very luminous, would be probably large and blue color, and then a less luminous would be a red giant, as its red color indicates less temperature or a cooler temperature. So this HR diagram plots the temperature of stars versus their luminosity, and then we can observe that the main sequence stars like the sun, they follow a certain trend which we call the main sequence star here. Now let's talk about the star that we focus on in our solar system, which is the sun. The sun is quote-unquote a medium-sized star. It consists mostly of hydrogen and helium right now, and it emits energy like infrared energy with visible light and ultraviolet regions as well, in a spectrum of electromagnetic spectrum. Now the sun is in the top 10% in terms of size, and it's powered by the nuclear reactions releasing energy due to the fusion of hydrogen and helium. The Sun is around 4.6 billion years old, and its surface temperature is 5,778 Kelvin. So now let's talk about the nuclear fusion that happens in any stable star, including our Sun. The hydrogen atoms inside the star will undergo nuclear fusion to form helium, and then following this reaction will then generate a huge amount of energy released in the form of light and heat. So the Sun every second converts 700 million tons of hydrogen into 695 million tons of helium. The leftover amount, which is 5 million tons, is then released as energy, as we said, as light and heat due to this fusion reaction. So the pressure inside the Sun balances the external pressure due to gravity, where the Sun does not collapse on itself. So the internal pressure due to the release of helium balances out the gravitational pressure from the external surface. So now let's talk about the life cycle of a star in summary. So we can say that all stars eventually will run out of hydrogen because they use it as their fuel. So once they use up all their fuel, they will form what we call a red giant or a red supergiant. So the red giant will form a planetary nebula, and the planetary nebula will then form a white dwarf star, which is luminous with high amount of light and also very dense center. And then it will eventually fade away and then form a dark dwarf, or black dwarf. Then the supergiant, the red supergiant, will explode and form a supernova, and this supernova will create the nebula that can create other heavier materials containing hydrogen and heavier elements, and then it will leave behind a neutron star, or it will leave a black hole depending on the mass of the red supergiant, how heavy was the red supergiant. A supernova is basically a powerful and luminous explosion of a star,